share my screen. All right. All right. So what we wanted to do is circle back. Now you probably already are familiar with these concepts, but I wanted to cover it at least because it's good proactive programming to know how to handle errors. And we may have covered them in our own way, but and maybe when we were doing arrays and objects, it would have been great to know this, but we were going so fast with the DOM and things like that. But it's good to circle back and actually know what error handling is, because in any language, you're going to need it. You can certainly not handle errors, and you don't always have to handle errors. But critical pieces of code where things can break, this will often save you quite a bit of problems. It gives you, again, more control over your coding because, say you're traversing the DOM or manipulating a list of collection or something like that. Even today in my current job, we have some production errors that are happening that are being logged that are so generic, we don't even know what they are. And there's like 500 to 1,000 errors in the last week since we did a release, and we can't even tell what it is because there's no good logging. So what that means is some exception or error has happened in our code and it bubbled all the way up somewhere, and we swallowed it somewhere or stuffed it, or we caught it somewhere, and we'll talk about catching. And we didn't handle it properly. So now we have no idea where it is, and we have no way of replicating that code. Big waste of time trying to find out, where it is, a lot of investigation. So error handling, this is what we need to learn about, because it can save us a lot of time. So error handling, we already learned about errors. And, the concept is, no matter how great we are at programming, sometimes our scripts have errors, and that's true. We may do our scripts and our coding really fast. And again, if you're not coming from a background of programming, there is a lot of concept of testing and also unit testing. And there's a whole methodology around test-driven development, which, I'll reserve my comments on that till a little bit later. I'll tell you that story in a little bit, but it was actually funny, a little bit funny. But anyhow, so these errors may occur because of our mistakes, unexpected user input, something happens on the server, and like lots of other reasons. So, a user or functions, a caller could provide some really bad data. Maybe there's a user trying to hack the website and do SQL injection. If you don't know what that is, it's basically writing database scripting and trying to inject it into forms. This is a real thing. This is a security breach. They might say delete all users and try to submit it with the hope that it'll be executed somewhere, which sometimes it can be. Lots of things, right? Lots of things can happen. A very common type of error would be, you try to get the certain index of an array, maybe at the position 10, but your array is only at, well, actually, I'll just give undefined. But there'll be other situations where maybe you want to convert a number to an array, or use some built-in methods and it'll throw internally exceptions. You need to handle them better, right? So what happens is a script can die, it'll stop, and you don't know why, you don't have no idea why it dies. Or you'll get a very generic error in your console, and like the situation at work, we don't know where it's happening, right? It's just our program or the web page dies, and you have to backtrack, try to reproduce your error, try to find out where it's happening, right? And then, you need to debug and things like that. So there's a better way to control this a little bit better, and there's this construct called try-catch. So it allows us to catch the errors. So the script so instead of dying, the script won't die. We can allow the page or the script to continue working while we deal with that error. Maybe you have a simple function like convert, convert an object or persist an object or store this or whatever that function does, even as simple as convert a date time or do a date difference. You don't want that function breaking your whole application, right? So in these situations, you can wrap it in something called a try catch. So this is what it looks like. It looks like a try catch block. So you can wrap all of your code. Think of your code that you've been working, I wouldn't wrap your entire program in try catch. I guess you could, but I don't think that's a good idea. So think of the functions that you've broken down so that you have little reusable blocks of code. And within those blocks of code, you can wrap them internally, that code block inside of try catch. So you protect it a little bit more. And therefore you can do some nice logging as well, right? So it looks like this. It has a try statement keyword with a block of code, right? We have our parentheses here. And this is where we can put all of our logic inside of there. If anything happens inside of this block, an exception will be caught, and then we can handle it so that it'll be catched here and execute this, right? So that basically protects your little reusable block of code from affecting anything else related to the page. So it works like this. First, the code in the try is executed in this block. If there are no errors, then it basically ignores the catch. So if there's no errors, everything is good. Execution ends here, it exits out of your function, right? However, if there is an error, then the try will stop. It'll fall through like a switch statement, if you were to think of that. Basically, it'll flow to this catch. And then inside of that, you'll have an error variable. So again, just so you know, this can be whatever you want it to be called. Some people just use an E. Some people write error. You know, you could say ERR, error object. Doesn't matter what it is. It'll always be the same type of object, and you're just defining a variable name here. So we can use any name for it. Doesn't matter what it is. It could be foobar for all we care, but don't use that. Again, clean code, right? We have to be descriptive on what it is. ERR at least tells me it might be an error. But again, there's a common pattern where E is used. And universally, I guess, in coding, E is like error. But if you want to be more explicit, you could type out error. But what is inside of that is something called the error object. And we already talked about objects before. So this is an error object with details about what happened. So you could figure out what happened in your code, and it's really great because you can either log this to the console, your browser, or if you had a database, you could log it in the database, and you could give a history of all the errors that has happened, which is really great for finding problems. And the more specific, the better. It's just really good for debugging. Like as an example, that production exception we're trying to track down, save us a lot of time because we have no idea where to look. It's so generic. Right, so we go back to one of these flow diagrams that we learned way back in the day. I forget when we learned this. Probably, I can't remember now. It's been full stack 1, or even when we looked at switch statements. Looks like this. So we begin our code, our function call, what have you. It could be just maybe even it could be just a script file. We're beginning. We hit that try code block. No errors, basically ignore the catch block and exit out of the program. Otherwise, if an error occurs, ignore the rest of the try and then go right to that catch block. So this is just a different way to visualize it. So an error inside the try block does not kill the script. We have a chance to catch it, right? So some control. So I'm going to run this out of this example, but this was using a browser. Excuse me, I put console logs here in my example, but this is an example of a program with no errors. So, and I'll run this in a minute. If you were to run this code, it'll give the first alert, give the second alert, and it'll ignore the catch statement completely. So I got this deal here. Again, I don't have anything wrapped in a function, and for today we will go back to our playground here. Again, you can put it in the browser if you want, not a problem. Right, so this is errorless program. If you notice, we're not even using a function here. It flows through console log, no errors. If you notice here, this is completely ignored, right? This console log will not run. So this is an example of an errorless program, which is great. There's no way we could have errors here because we just have console log. So there's no arithmetic happening. Pretty straightforward. This is an example of a program with an error. So we have the same deal there. Actually, let me see here, 1 and 3. So I think I didn't put an error in this slide, but there should be an error, I would think, in my error here. Here you go. Sorry, I missed this part. So what I did in here was I added same bit of code, and I just added some variable. I just put what doesn't even matter what it is. But normally that would, normally on its own, it'll actually say error, variable is not defined, right? And it'll break our code. But what will happen here is when it tries to throw that, we'll catch it here. And instead of saying error, variable is not defined, we're just going to control what we're doing here. We're going to actually output that error has occurred. So you can see that by the console here, it starts the run, starts it right here. Once it hits there, the default behavior would be output this, right? Let's actually look at this. If we actually put this outside of the whole block, we'll probably get a nice red error, right? Let's run it. So we'll get this gigantic reference error. You can see this big messy, and if you look at it, you won't even know what's going on, right? Where is it happening? It's very convoluted and it's not very descriptive of what's happening, right? So if that happened and we don't want to necessarily show this error to the users or an application, we control it in a nicer way. And if this was in a browser, by the way, we have the concept of the console log, and we have a concept of console error. And this will actually show up in the browser. Sorry, I have a question. If it ignores the rest of the code in a try, does that mean it won't be able to catch multiple errors? If it ignores, yeah. So when an error happens, it basically the first error will trigger the catch, and then the code will stop executing. Meaning that if you had another variable in here like this, it'll hit this one and it'll exit out. It won't do multiple errors because you're basically catching that first exception, and you're going to hopefully deal with that exception. And then if you deal with that exception, you'll uncover this one, right? You'll uncover this piece right here. So sometimes you have multiple errors and multiple problems with your code, multiple bugs, and sometimes solving one bug uncovers one or many other bugs, and you have to keep, and that's why it's a good thing to always, you don't always have to do it, especially if it's a piece of code that's very simple that should never throw an error like this. Like here's something that will never throw an error, and it would be overkill to put a try catch around it. But if it's something where has a high potential of breaking due to data or some kind of mathematic or collection lookup or something, it's good, but you don't have to use it all the time. You don't have to use it for very small things like set visibility or something you could trust, like, and when I say trust, I mean something like wiring up event handlers to DOM objects, right? You can kind of trust they're always going to be there. You might not need to wrap it in a try catch, right? You got to use your own discretion, and that only comes over practice, right? Time and practice. So yeah, visualize that there was a variable there with that one. So you got to remember that this only runs it's during runtime when this happens, right? So for try catch to work, the code must be runnable, and otherwise it must be valid. If it's not valid, if the code's syntactically wrong, it's not going to run. It's not going to catch that problem. So you can see here in this example, I would try, and I have a bunch of syntax errors. It's not going to run at all, anyways. It's not going to solve this problem, right? It's meant for runtime errors. So the JavaScript engine And we haven't talked about engines yet. When we get into Node.js, we're going to talk about what a JavaScript engine is. But what it does is it reads that code, it reads it, and then it runs it. The errors that occurred in the reading phase are called parse time errors. So it's parsing your code. So they're recoverable from the inside of that code. The engine can't even get to that point because there's a parse error with the whole script, right? So it's not going to be able to run it. So try catch is for valid code, and these errors are called runtime errors. And you'll often hear of exceptions. Exceptions, you'll hear that a lot. Runtime errors, exceptions, they kind of go back and forth between those. So just know when you're talking about exceptions, you're dealing with runtime when the script is executing. So I have something like this. Look at this, same kind of deal. Already you can see that so by the way, if you're not familiar with this, we may have covered it, but Visual Studio Code will start to highlight this. And this is called, it's called linting. It's basically a linter. There's different linters like ESLint and Beautify. And it's basically trying to tell you that there may be something wrong with your syntax. Like you'll see the squiggly line here. It doesn't mean that you can't execute it sometimes. It just is giving you like some kind of feedback that maybe there's something wrong. But in this case, there is a lot wrong here. If I try to run this in our compiler here, you'll just see it die right away, right? It's going to die. It's going to say it doesn't even register the fact that that's a catch because of all of these unmatched parentheses, right? Total, it's just messed up, right? Even if you had a couple, again, with programming, if you have like an extra one in there, like we're overkilling here, but even if you have an extra bracket that doesn't match up, like sometimes you need to match up, like this one will match up with this one. Normally, this one will match up with that one, right? But if you have extra ones in there, and that's what's difficult about programming is how detailed it is. You need to close your brackets, close your HTML tags, put semicolons in. It's a very detailed business. It's you almost need to be a little obsessive compulsive about things sometimes. But anyhow, so it's not going to even hit that code, and that's something that happens. So it's runtime, and it needs to be valid code. So we haven't learned about asynchronous JavaScript yet, but there is the concept of set timeout, and we're going to cover a lot in Node.js. So basically, by default JavaScript is synchronous, but we can make JavaScript work in an asynchronous way using those APIs. So there is something in the API called set timeout. And while I mention it to you, we will definitely be using MDM set timeout. We're going to be using this stuff with Node.js because Node.js is all about that. I wanted to grab that. Is it here? Developer snippets? No. Yes, it is. The web docs here. Set timeout. There's a bunch of them. So basically what it is it's a way to add a timer to something. So you can actually, let's actually look at this. So what it does, it'll set a timeout. It'll actually put, so what this translates to is on every 2000 milliseconds, it'll throw an alert. And it'll just keep going until that is up. So after 2 seconds, this is not a recursive function. This is just adding a delay. So show an alert box after 2 seconds. So when I click it, it's going to wait 2 seconds before the alert fires. So you'll see right now that was slow, and you can cancel it as well. It's just a mechanism for allowing control of time inside of your JavaScript. And you can also, you could do a for loop or a while loop, and you could create some asynchronous stuff, right? Because normally JavaScript, when we mean synchronous, it's like it executes one line, it goes to the next line, it goes to the next line, it goes to the next line. That's called synchronous code. This allows you to mix it up a little bit. And again, we're going to get into more asynchronous stuff in the second part, but just be aware of what set timeout is, because we are going to start delving into that. So basically what this is saying here is I have a timeout and it's going to be 1 second. And I put a variable in there where it's going to die. But what happens is this try block will go and execute. It's already done. This is delayed 1 second later, so I'll never get caught. So try catch works in a synchronous way. It's a little bit tricky. This is a tricky concept. We'll get into it. Just the point is, JavaScript is synchronous. Try catch works in a synchronous way. In this scenario, it won't be caught because the function is executed later and the engine is already left, right? There's a concept of callbacks, and we're going to get into that a lot in Node.js and asynchronous JavaScript. Just remember, JavaScript is synchronous. So if we wanted that whole thing to work, we would have to put that try catch within the set timeout because our JavaScript is executed. This whole thing fires 1 second, 1 minute, 10 minutes from now. When it fires, then that try catch will work because it exists in that time period, right? It exists in the time that this function runs. So it's a little bit of a strangeness to think about, right? We've only dealt, so I'm just introducing this in a little bit of a small way. We're going to dig into it a lot more as we go further in JavaScript, that there is this concept of asynchronous and synchronous JavaScript, right? All right, so let me quickly run this and I'll just demonstrate the fact that it's not going to be caught. If you can see there, so it has a timeout. It ran right away. It didn't actually catch it, right? But it did catch it later on. So if I put this to, say, I don't know, 5 seconds, we'll see a little bit of delay. When I run it, it doesn't throw the error right away until after 5 seconds. It should, there you go. See, you notice that little bit of a pause. So if we run it again, it executed. You can see that there's a timeout function there, and 5 seconds later, it'll actually throw that error. And we can increase that to like 5 minutes, 5 hours, 5 days. 5 days from now, that script will run, that error will be there, but we won't see it right away because it's deferred until later. Bigger concept, but this is what makes some really cool stuff happen, you know, when you get into this kind of stuff, right? Right on. So just remember, JavaScript is synchronous, although we have many tools to make JavaScript work asynchronously. So there is a newer addition to the language where it's really nice. The catch is not always needed. It's optional because sometimes you just want to catch something and not do anything with the error. You just want to catch it. Maybe you don't want to do anything. Maybe you want to, as a side effect, log something. But the old pattern was you always needed to put that parentheses with the E in it or the error. Even if you didn't use it, you needed it, the browser would break, you know, the script would, there'd be a problem. So this is nice. So one of those newer features, recent addition to the language. And when they say older browsers, they're talking like IE, you know, those older versions of IE 9, 10, 5, and 6, whatever, right? 5 through 10. You need something called a polyfill. If we never talked about what polyfill is, sometimes those are like external scripts just to kind of include it just for those older browsers so they get it, you know, they understand it. Otherwise, they'll throw some huge, like I told you, I broke IE 10 or 11 because I put ES6 syntax in there. And the JavaScript engine itself that ran in that browser just said, I don't know what you're talking about, and it broke the application. So there's times you don't need it. So you just don't, you just do not include it, right? It's optional. Another thing is we talked about this error object already. This error object has some attributes on it. As we know with objects, it's how we'll have a key value pair. So when an error occurs, JavaScript generates an object containing details about it. The object is passed as an argument to the catch, right? We already established this pattern. The error object in this example is ERR. Again, you can use any other name for that variable. But within that object, it has two main properties, and the properties is name, so the error name. So for instance, it kind of gives you a little bit of an example. It kind of tells you what kind of error it is or the type. So if it's a reference error, then you may handle a reference error then. You kind of have an idea, maybe there's some variable that's not assigned. It gives me a little bit of a specific kind of place to look. But then there's a message, right? So it's usually some details about what happened. There are non-standard properties available. So it's saying most environments. One is most, so also there is a stack. So most times people ignore the stack, and it's, let me just minimize this. Current call stack, string information, as we noticed already when we ran this, right? Even just putting some random variable like this and running it, you will see this is the stack, right? This is the whole stack here. You can see here, this most likely is the name, reference error. This is the message, right? And then this is the stack. And a lot of people, you know, and for friendly messages anyways, they just kind of maybe will reference this and ignore all of this, all these lines of code. But you have control about what you want to include in your logging if you just want to, and how to handle it. So there's ways of using that error object to break things out. And there is a reference. It's a global object inside of our web docs. So we'll read up on this error object, right? And the different things the different types. So there's a lot of different types. We only talked about the reference error, but you know, there's some internal errors. Some of them I'm not too familiar with, to be honest. And sometimes it takes me, okay, what does that mean, right? What exactly is I don't know. What is a range error? Okay, well, that's saying that something's out a numeric value. What's a URI? Okay, well, then there's something with encoding going on there. So it gives you a place to look instead of some generic message that you don't know where to look, right? So again, it's an object. So we can actually, before I get into that, I have an example of the error object. So same deal as what we did before. If we have that, that variable there, such as there, we can actually inspect some of this stuff. So we know that it's going to throw variables not defined like we had right here. But we want to catch it and we want to actually output some things, right? So if we actually output this now, let's actually get rid of that stack, because that stack is pretty annoying. So let's look at this. So now we just focused on the name, which is error reference. We focus on the actual message itself. This variable, what's the variable? Okay, it's la whatever, LALA is not defined. Then I know where to look. I say, okay, well, I just need to go and define this variable, right? What would be proper syntax like that? Now my error has gone away because I actually defined it. If I have no definition, then it's just sitting there. It doesn't know what to do with it, right? If, however, I want to look at the stack only, then I can control inside of that error object. There is a key value pair, and one of the key value pairs would be stack, right? If I use dot, you can see in my IntelliSense here somewhere, what happened to my IntelliSense? It was there a minute ago. But anyhow, you'll see name, message, stack. Maybe I'll go back to some editor that actually works. There you go. You'll see error. You'll see the error object itself. You'll see the message, the name, the stack. It's not a very big object, but it just gives you control. So you can see here is the stack, right? What you do with this, I don't know. Maybe you want to, you can get as complicated as you want. You can have a global handler that handles all the different types of errors. You could have you could just basically log, like I said, you could just log the name in the message. Otherwise, you might want to just log the whole error. So you can output, you can dump the whole object yourself here, and basically you can do something with that, right? So again, it just shows you that you can break apart this object and do with it what you will, right? There's more logic to be added onto this, depending on your need. Right. So also, you can also, all right. So talking about control. So we've talked about catching errors. You may actually need to throw your own errors. So you can kind of visualize this in the sense of you have a bunch of you could have a bunch of try catches in multiple levels of your program, and sometimes you may want to you come across some logic and you need to throw your own error with the hope that on one of those other levels there'll be a catch that's listening, and based on that catch it has other logic. So you can kind of see already, like, you can be throwing errors back and forth. It can get really complicated, right? Because sometimes you don't want to stifle something. Maybe you want to roll back. Maybe you have something like, okay, there was a data error. I need to roll back the database, but I don't want to suppress that error because everybody else needs to know about it. I'm just going to take some proactive measures, roll back the database right. Then I'm going to throw an error back up to anybody who's listening to let them know, hey, I rolled the database back. There was a really big error that happened that you guys need to worry about, and you need to know about it. Because if you suppress it, people will be like, hey, the database rolled back. I don't know why, right? So you may need to have that other control where you're throwing errors of yourself. And when you're throwing those errors, you might want to give it a very descriptive message saying, hey, an error occurred at the database write. I'm just letting you know that I rolled back, but you guys need to, there's something that happened. There's some bad data coming from the UI. We're rolling back right now because of it. So that's another good way, right? So if you're throwing, you use that syntax called throw, and then you're going to create like an error object. And again, when you think about error objects, you may need to new it up. You may need to create a new error object and treat it as any other object, right? So we can use anything as an error object, and maybe a primitive like a number. So yeah, you could use a number, you could use a string, that's true, but it's better to use that built-in object called error object because it has a name and a message property, and you can basically be very descriptive of what happened. If you just throw an error and say, I'm throwing the number 2, well, I mean, what does that do for anybody, right? So here's an example of, all right, so here's a good example of why try catch would throw here. Before I get into throwing our own errors here, so here we go. We have bad JSON. So bad JSON would be JSON. The JSON object is just like an object. It needs a key value pair, right? So we have no key value pairs in there. It's just basically a bad formatted object. There are some things around JSON we haven't learned called JSON parse, which will parse a nice JSON object for us by key value pair, but it's going to explode right here. So it explodes because of the bad data. So this is not something you did. This would be some data that's passed in. When you have bad data, you have to control it, right? So we catch it. We just say, hey, there's some bad data. We're just letting you know, but keep going, right? Because you may have lots of data coming in. This one was bad. The next 100 records may be good. So there's no point in stopping our program just for some bad data. On to the next, right? That's kind of a situation that may happen. So I'm sorry, there was a question. Go ahead, I didn't see it. Go ahead, you had one.
So typically for error handling, we use objects, but there is also a concept for exit setup. And
Sorry,
with
exiting?
exit setup, like 0 if everything was correct, and if it is yes, then So basically, there would be error codes. Like one would mean something, two would mean something. And when exactly do we use that of a methodology? And when exactly should we use objects and error handling?
Exiting, exiting is more procedural, I guess. Exiting a function with a code is more, it's more older school. It's not web specific, right? It's not, to be honest, I don't use exiting that much with error codes, especially with the web. I honestly cannot tell you a time in the last 5 years where I've used exit with a code. Maybe if you were running more of a server-side desktop kind of application, maybe you would use that. But honestly, with web, I can't actually remember last time I used it, to be honest. So I know the pattern, but try catch, you'll see with asynchronous is so important. It gives you a lot of control over everything, right? Because if you just exit out of the program, you exit out with a code, but you have to go and look up what that code means. Whereas if you're handling objects, number one, you're not stopping execution. You're not stopping it dead. You're allowing execution to continue, and you're handling the object in a way, maybe you're logging it, and you're giving descriptive debugging information to allow for system errors to be tracked down and solved, right? So it's very important. And to be honest, you use it almost everywhere there's complex interactions happening. Or situations like this, bad data should not stop my whole shopping cart from loading, right? I want to buy something, some bad data should not stop my experience. I should be able to continue on and navigate the site, adding, with my shopping. Just because there's some product that has a bad price should not affect my experience. So yes. Right, so throwing our own errors. So again, there's different types of errors, and there's a general error. There's syntax errors, reference errors. Sometimes you may get in a situation where you might need to, you don't need to be so descriptive as saying, hey, there's a syntax error, and I don't need to really give much more information by that. So by just passing that object back, somebody will know what happened, right? You don't have to even tell them what happened. So they'll know there's a reference error or the syntax error. You could use a general error. That's perfectly fine. But you can actually push up a type and someone can respond to that type in that way. So, all right. So here's an example of a little bit harder example, I guess. But let me take a look at this one here. You guys have listened to me a little bit. So same kind of deal. I'm going to console log this, though. It'll never reach this point here. Console log, console log, console log, console error, not console log, console error. All right, so what happens here is I have a JSON object, basically an object. It's looking for the name, but the name doesn't exist. So if you notice, I have a check here. Does the name exist? If the name doesn't exist, I'm throwing my own error, which is called I'm using the throw keyword. I'm using a syntax error. I could have just put error like this. That's not a problem. And I'm throwing it because I know somewhere down in the code, and the code can be very long. It could be like thousands of lines of code. I'm going to catch it because there's a problem there. And I'm going to report back, hey, there was a JSON error, by the way. This key is not in this particular piece of data. And I'm not going to do anything more than that. And I'm going to let the execution continue until such time as somebody passes me another JSON object, in which time, if it is valid, then it'll continue on and do whatever it needs to do down here, right? More logic. Maybe down in that other logic, I do another check for age. And if age is not there, I can throw an error, and so on and so forth, right? So it allows you to continue, right? Because if I didn't have this catch here, I didn't have this, well, what would happen? I just have some big error happening, right? And it stops my program. Dead. It says couldn't share your system audio. So let's see for a second here. I actually do have I'm gonna stop sharing for a second here. I'm gonna stop recording. Stop recording.